Today, our group will present about data communication and computer network. Firstly, my name is Muhammad Daniel bin Marazi, and our second member is Afiq Aiman bin Abu Karim, and our last member is Firas Hamzah bin Arba'in. And firstly, what is data communications? Data communications is the exchange of data between two devices via some form of transmission medium as well as cable. And the second important thing, what is computer network? Computer network is an interconnect connection of device which spread into three types, which is first, cooperative, mutually suspicious, and autonomous. What is cooperative? Cooperative is action is required between components, and the second thing about cooperative is no master-slave relationship. And mutually suspicious is the component verify request. And what is autonomous? Autonomous is all components are capable of independent action. And the last thing about autonomous is any resources is capable of refusing requests. And for the questions 1, for each of the following phone network, discuss the consequence if a connection fails. A. Fast device arranged in a mesh topology. B. Fast device arranged in a star topology. And C. Fast device arranged in a bus topology. And D. Fast device arranged in a ring topology. So, we will discuss all of this from A to D. And firstly, we will discuss about question 1A. First device arranged in a mesh topology. And first difference, what is mesh topology? Firstly, every node is linked to another node. And second, not practical for geographically distributed user. And the most important thing about mesh topology is very costly. And the answer is, so what happens if a connection fails? For mesh topology, if one connection fails, the other connection will still be working because the another every node is linked to another node. And for 1B, fast device arranged in a star topology, not counting the hub. So, what is star topology? First, oldest and most common network design. And the second, multiple nodes attached to a central hub. And the third, physical, all nodes connected to a central node. And the last one, logical, all data pass through the central node. So, what happens if a connection fails in star topology? And the answer is, the other device will still be able to send data through the hub because there will be no access to the device which has the failed connection to the hub. So, question 1C. Fast device arranged in a bus topology. What is bus topology? First, about topology is single cable connects all computers. And second one, terminators signal the physical end to the segment. And the third, physical, each device is on the same wire. And the last one, terminators signal the physical end to the segment. So, what happens if a connection fails in bus topology? And the answer is, all transmission stops if the failure is in the bus. If the drop line fails, only the corresponding device cannot operate. And for the last question, fast device arranged in ring topology. What is ring topology? First, computer connected in cascading order to make a closed loop ring. And the second is the source station transfers the information to the next station on the ring, which check the address of the information. And the third, continuous path for the data with no logical beginning or ending point. And thus, no terminators. And the fourth, logical. Each station pass data to the adjacent station. And the last, physical. Device wired in a DC chain. So, what happens if a connection fails in ring topology? And the best answer is the failed connection may disable the whole network unless it is a dual ring or there is a bypass mechanism.
Okay, now we move to the question 3. Compare the telephone network and the internet. What are the similarities and what are the differences? What is telephone network? A telephone network is a telecommunication network that connects telephones to make voice or phone calls between two or more people. It is regarded to be the first electronic network. Analog techniques are used extensively in telephone network as opposed to the digital technology used in computer-based networks. What is the internet? The word internet refers to global network of networks that use the internet protocol to interact with one another. It's a collection of local and international personal, social, educational, industrial, and political networks linked via a variety of electrical, wireless, and optical networks. It has such a large and powerful capacity that it may be utilized for almost any information-based purpose, and it is accessible to anybody who connect to its representative network. Okay, now we move to the similarities between telephone network and internet. First, both the internet and telephone network need circuit and packet switching to operate. Second, communication might take place through cable or wirelessly over the internet and telephone network. Third, the internet and telephone network are both public networks that deliver network service. Lastly, both provide data transfer from beginning to finish. Now, we move to the final part of this lesson. The difference between telephone network and the internet. Refer to the table as we can see. The transmission telephone network use optical fiber, while the internet use coaxial cable and optical fiber. Look at the network element. The telephone network use CPE, switch marks, and cross contact, while the internet use hub, switch, bridge, router. The bandwidth of the telephone network is static. It uses 64 kilobytes per second, while the internet is dynamic. It will take from kilobyte per second until megabyte per second. The transmission system for telephone network is analog and digital, while the internet is digital only. The switching approach for telephone network is circuit switching, while the internet is connectionless packet switching. Next, we look at the multiplexing. The telephone network uses a circuit multiplexing, and the internet uses a packet multiplexing.
Next, we will look for question 3. The question is: an internet service provider is granted a block of addresses starting with 150.80.0.0/16. The ISP wants to distribute the blocks to 2,600 customers. Okay. The question needs us to design the subblock and give the slash notation for each subblock based on the criteria given. That is, the first group 200 medium-sized business, each needs 128 addresses. The second group has 400 small business, each needs 16 addresses, and the third group has 2,000 household, each needs 4 addresses. Okay, we'll also need to determine how many addresses are still available after this allocation. Okay, before we answer this question, we must know what class of IP address for these addresses, so that we will easy to answer the question. Okay, so the class is IP address class B. This is because the addresses given was 150. It is in the range of 128 to 191. Okay, this class B is starting from 128.0.0.0 until 191.255.255.255. Okay, other than that, for class B, it will have 16,384 blocks from net ID 128.0 until 191.255, and this class B will have 95,536 addresses in each blocks. Okay, now let's answer the question. For the first group, each business needs 128 addresses. This means that 7 bits are needed to define its host. The prefix length is 25. Okay, so the addresses are for the first business is 150.80.0.0/25 to 150.80.0.127/25. For the second business is 150.80.0.128/25 to 150.80.0.255/25. For the third business is 150.80.1.0/25 to 150.80.1.127/25 up until the last business, that is 200 business, is 150.80.99.128/25 to 150.18.99.255/25. So the total address for this group is 200 multiplied by 128. You will get 25,600 addresses. Okay, the next address start with 150.18.100.0. For the second group, each business needs 16 addresses. This means that 4 bits are needed to each host. The prefix length is 28. So the addresses are: the first business is 150.80.100.0/28 to 150.80.100.15/28. Okay, second is 150.80.100.16/28 to 150.80.100.31/28. And the third business is 150.80.100.32/28 to 150.80.100.47/28 up until the last business, that is the 400 business, is 150.80.124.250.280.124.255/28. So the total for this group, the total address for this group is 400 multiplied by 16. We will get 6,400. Okay, so the next address will start with 150.18.125.0. Okay, for the last criteria for the group 3 is household need 4 addresses. That means that's 2 bits need to define its host. The prefix length then is 30. So the address the first household is 150.80.125.0/30 to 150.80.125.3/30. For the second household is 150.80.125.4/30 to 150.80.125.7/30. And the third household is 150.18.125.8/30 to 150.80.125.11/30. Okay, we will skip to the 64 household, that is 150.80.125.252/30 to 150.80.125.255/30. We will continue up until the 1984 household, that is 450.80.155.252/30 to 150.18.155.255/30. And the 1985 household is 150.18.156.0/13 to 150.18.156.3/13 up until to the last household, that is 2000 household, is 150.80.156.16.60/30 to 150.80.156.63/30. So the total address for this criteria is 2000 multiplied by 4. We will get 8,000 address. Okay, so the next address available from 150.18.156.64. Okay, we know that for the class B IP address, it will have 65,536 addresses in each block, and we had used 40,000 addresses from this question. So the addresses that still available after this allocation is 25,536 addresses. Okay, that's all from us. Thank you.